something is not quite right, right? If ferritin is an inside the cell protein, why is it in the serum? And why do we act like the fact that we don't know that is not important when we're using the outside ferritin as a marker of health? That doesn't make a whole lot of sense. And then how might iron's relationship with inflammation alter its serum tissue balance? That's the, well, does inflammation affect ferritin, or does ferritin affect inflammation, and how does that change? And then in states of iron overload, of which I have kind of focused on in terms of its role in the development of diabetes, how, if iron excess in the cell is what's dangerous in causing this inflammation, how do we actually know that a cell is overloaded, right? Do we have a good metric to find out what the cellular status is of its iron content and the quality of its iron content? You know, is the iron in the cell bound to ferritin or is it not? That is a critical point, because if iron isn't bound to ferritin, that's what's dangerous. And that's what we need to know. And then any updates, right? The world continues, the medical world continues, and it's just, oh yeah, serum ferritin, serum ferritin, serum ferritin. And none of the modalities that we're using to address it are actually helpful. Health continues to decline, iron status continues to be ambiguous, and we're acting like everything's okay. So I love this picture. What is ferritin doing outside the cell, right? You see a sofa at the curb and you're like, I mean, technically, yes, it's allowed to be outside, but it's definitely not supposed to be outside. And everyone knows that an outside couch has significantly different characteristics than the inside couch, okay? And we're, here we are trying to pretend like the outside couch is the same as the inside couch. They're not, okay? Ferritin is an intracellular iron storage protein designed to bind and neutralize iron's volatility while it's being stored inside the cell. The molecule itself, and it's not this color, this is colorized, but this is what the molecule looks like, and I think it's pretty cool. It forms like a cage structure, okay? And inside this ferritin molecule, if you can kind of, it looks like you can see through. Inside is where the iron molecules are being kept. Now, one of the most fascinating parts about ferritin is that it is very highly conserved, which means that in just about every single living thing on this planet, from bacteria to plants to mammals and reptiles, everything you look at, it has ferritin or some form of ferritin. It has been around a very, very long time, which speaks to the significance of iron and iron regulation in life, right? Every living thing needs to have a way of managing iron and neutralizing and storing iron. It's important, okay? Now, I mentioned before, transferrin doesn't hold a lot of iron. Ferritin does. Ferritin can store up to 4,500 iron molecules in one ferritin molecule. That's pretty cool. Transferrin can only hold 2. But like I said, the volume of transferrin makes up for that. But every human cell in your body has ferritin. Needs iron to create energy, needs to be able to store and neutralize iron while it's there. Now, when we talk about how iron got outside of the cell, there's a couple different theories on how exactly that happens. There are 2 extremes on either side of the spectrum, and then there's kind of an intermediate between the 2. The first one is that, well, that's just how it's supposed to be. There's a ferritin that can be inside, and there's a ferritin that can be outside. Ferritin can store and neutralize inside the cell, but it can also serve as a transport protein as well. Why not? The second, which is on the opposite extreme end, is that Ferritin is absolutely not supposed to be outside the cell. And the only way that that ferritin can get outside of the cell is for the cell to basically die and expel its contents into circulation. So it's like it's exploded and it's just sending ferritin into circulation. And we're measuring, when we measure serum ferritin, we're measuring the contents of our dead cells and pretending like that's normal. The intermediate, the kind of happy medium between those two extremes is that ferritin is meant to be inside the cell. And in certain physiological conditions, ferritin can be a regulatory protein in reestablishing balance to ensure iron is being managed properly. Okay. Not supposed to be a transport protein, but serves a role outside of the cell that helps it get back to a state where it can be inside the cell.